last class we completed limiting reagent. Let us see one question based on the limiting reagent. Note on the question. "14 grams of N2 reacts with 4 grams of hydrogen to form NH3. Find amount of ammonia formed. Find amount of ammonia formed." Applications of limiting reagent. First write the equation, balanced equation. N2 plus 3H2 gives rise to 2NH3. You have to write this reaction. Okay. What is the step 1 in the limiting reagent? Finding moles. N2, how many moles are given to us? 14 moles. 14, sir, weight 14 grams. 14 by gram molecular weight of nitrogen gram molecular weight 28. Next, hydrogen weight, how much given for us? Hydrogen 4 grams. 4 by gram molecular weight of hydrogen 2. Gram molecular weight of hydrogen is 2 only. We have to take gram molecular weight only. Don't consider coefficients here. What is the formula for number of moles? Weight by gram, that's all. Weight by gram molecular weight only. No need to consider the coefficients, right? Here common mistake is students will take 3 molecules are there, no? So 6 they will take 2 into 3, but that is wrong. Number of moles means simple formula, plain formula, weight by gram molecular weight. Okay, right. Here 14 by 28 means 1 by 2. 1 by 2 means 0.5 and here 2. Okay, moles were identified. Moles. What is the next step, Juhi?
Mole by coefficient.
Division.
Yeah.
Division. Next step, mole by coefficient. Mole divided by coefficient. What is the coefficient for N2? N2 coefficient 1. So 0.5 by 1. Coefficient here 3. This is 0.5 and this is 1.5, 0.6. 0.6. Which is least value? 0.5 is the least value. That least value gives us about limiting reagent. So N2 is the limiting reagent. Yesterday we completed up to this, finding the limiting reagent. We did how to find limiting reagent. The next step, what is the use of limiting reagent? See, in reactions like this, limiting reagent decides the moles of product formed or amount of product formed. See, here ammonia is forming. How much ammonia is forming? That depends on the limiting reagent, related to limiting reagent. The product moles decided by limiting reagent only. How? Let us see. Okay, after completing finding the limiting reagent, once coming to the well balanced equation, see the next step. After finding LR, coming to the well balanced main equation. According to the main equation, how many moles of nitrogen is giving how many moles of ammonia?
1.
According to standard equation, 1 mole. 1 mole is giving 2 moles of ammonia, 2 moles of NH3. Okay, 1 mole of N2 is giving 2 moles of ammonia. Coefficients, based on the coefficients. According to limiting reagent, we have to write the product moles in the standard equation. According to limiting reagent moles, we have to write the moles of product in the standard well balanced equation. Right. We are ignoring this 3 moles because this is not limiting reagent. Okay, omit this. Next, according to standard reaction, 1 mole is giving 2 mole, but according to the data, according to this data, what are the moles of N2? N2 moles 0.5. Clear? Right. After writing the moles according to the standard equation, write the moles according to the data. We calculated moles already. Clear? This is moles column. 0.5 moles will give how many? 1 mole gives 2. 0.5 gives question mark 1 mole. 2 cross multiplication. X is equal to 2 into 0.5, that is 1 mole. 1 mole of ammonia is produced in the reaction. So we got moles of ammonia. But what is the question? Find amount of ammonia. Find amount of ammonia formed. If we know moles, we can find weight. Amount nothing but weight. Then what is the weight? Calculate. You know moles. Number of moles are 1. What is the answer, online students? 18. So number of moles of ammonia is equal to 1. We got 1. What is number of moles formula? Weight by gram molecular weight is equal to 1. We have to find weight. Weight is equal to 1 into gram molecular weight. What is the gram molecular weight? 18. 17. NH3. Nitrogen is 14. 14. 3 hydrogens are there. So 17. So amount of ammonia formed is 17. That is the use of limiting reagent. Very important model question. You will get weights of 2 reactants. We have to find amount of product formed. Okay, then we use LR concept, limiting reagent. This is one model question, and another model question is, what is excess reagent and how much moles are excess? After reaction, how many moles left? What is limiting reagent in this reaction? Nitrogen is the limiting reagent. Okay, what is excess? Hydrogen is the excess. How much amount it is excess after completion of the reaction? How to find? We completed one model question, finding the amount of product. Okay, next, finding amount of excess reagent or moles of excess reagent. Let us see how to find moles of excess reagent or amount of excess reagent. This is another question. Sometimes you will get like this. In the following reaction, what is the excess reagent and find the amount of excess reagent, like that. Once observe this. How many moles of hydrogen left after the reaction? Remains, sorry. How many moles of H2 remains? How to find? See. What are the moles of ammonia according to the data? According to the data, what are the moles of ammonia? H2, sorry. According to reaction data, 2 moles. Okay. Out of 2 moles, how many moles are combining with N2? Okay, calculate that. Are you getting? We have 2 moles. Hydrogen moles are 2. Out of 2 moles, how many moles are combining with H2? Find out that. After getting that, subtract. Initially, you have 2 moles. Out of these 2 moles, how many moles are combining with N2? Right? Let us see. According to the standard reaction. For 1 mole of nitrogen, how many moles are required? 3 moles are required, right? See the heading, finding excess moles. Finding excess moles. Or excess reagent, moles of excess reagent. Okay. According to, again coming to the main equation, according to the standard equation, 1 mole of N2 is utilized by how many moles of H2? 3 moles of H2. 1 mole of N2 is utilized by 3 moles of H2. Clear? Now, here how many moles of N2 is there? 0.5 moles are utilized by how many moles of H2? Means how many moles of H2 is required to combine with 0.5 moles? Are you getting the question? 3 moles of H2 is required to react with 1 mole of N2 according to standard equation. This is another question actually we are doing. One important frequently coming question is over. Next one is 1 mole of N2 requires 3 moles of H2. Okay. Then 0.5 moles of N2 requires how many moles of H2? Do cross multiplication. Do cross multiplication. X into 1 is equal to 3 into 0.5. How much? X is equal to 1.5 moles are required. 1.5 moles are required to combine with 0.5 moles of N2, right? So 1.5 moles are required to react with 0.5 moles of N2, right? Initially how many moles of excess reagent we have? Initially 2. Out of 2, how many moles are utilized? So remaining moles are 0.5 moles are excess. Got it? So initial moles 2, utilized moles 1.5, remaining moles 0.5. So we completed excess moles also, moles of excess reagent. Okay, online students. Heading is finding excess moles. Finding excess moles. నువ్వు రోజు లేట్గానే రమ్మా, ఏదో ఒక రోజు డోర్ వేసేస్తా నేను. ప్రియాంక చూడు అడ్వాన్స్ వచ్చి కూర్చుంది పాపం 15 minutes ముందే. ఎంత పంక్చువాలిటీ. Note down initial moles of H2 2, correct only na? Utilized moles 1.5, moles of H2 remained, moles of H2 remaining 2 minus 1.5, that is equal to 0.5. So 0.5 moles of ammonia H2 will remain after reaction. Okay, if we know moles we can find the weight also. What is the weight? Tell me, what is the weight of hydrogen? We got moles, we can find weight. Number of moles of H2 is equal to how much? Then number of moles, weight by gram molecular weight is equal to 0.5. Weight by what is gram molecular weight of hydrogen? 2 into 0.5. So 1 gram of H2 will remain after reaction. 2 model questions will come. One is finding limiting reagent. Okay. Next model is finding amount of ammonia formed or finding amount of excess reagent. Okay. Expected questions on the LR. LR questions are very important. Limiting reagent questions. This is bit tough question. Remaining are easy only. Finding LR is direct, very simple. Finding amount of product also very easy. Excess moles finding only little bit tough, but if you practice then you will get. Note down as easily. We will do the questions. Takes time. See what we will do daily. We'll add 2 to 3 questions in physical chapter. Okay, it is better because if you do 20 questions daily means you will feel boring. So what I will do, in every physical chapter I will add 2 to 3 stoichiometry numericals, because this is basic lesson, no? So we should not stick here only. After getting basic idea, then we can move forward. Daily I'll add, no need to worry. Okay, about limiting region. Next, keep reading. Empirical formula. Empirical formula. My sister వస్తుంది శ్వేత. నువ్వే లేట్ వచ్చావు అంటే నీకంటే ఎవరు లేట్ వస్తుంది శ్వేత. ఎంపెరికల్ ఫార్ములా లేవలేదా శ్వేత? నువ్వు ఇంటి దగ్గర పడుకుని పోయావా? ఎంపెరికల్ ఫార్ములా, ఎస్ చెప్పండి. ఇస్తాను, నేను ఇస్తానమ్మా. ఐ విల్ సెండ్ ద నోట్స్, కాన్సన్ట్రేషన్ టర్మ్స్, stoichiometry notes also. Okay, empirical formula. And next oxidation states is there, then we can close theory part. Theory శ్వేత కనబడుతుందా? ముందు కూర్చోపోయినా నీకు? ఓకే, యువర్ వాచింగ్ ఇన్ దట్. empirical formula. Molecular formula, empirical formula, compound. What is glucose formula? C6H12O6. Do one thing, Shweta. Shweta, divide with 3. Divide this with 3. C2H4. Okay. Divide with 6. See, this is a molecular formula. Okay. These two are other formulas obtained by dividing with some numbers. Okay. గాయత్రి నేమ్ అనలేదు, లేట్ అయింది చాలా, నేను మీకోసం వెయిట్ చేస్తున్నాం. మేము see, we obtained two formulas, right? Molecular formula, and these two are some other formulas. How we obtained these formulas? By dividing with some numbers, right? This is one formula, this is one formula. Once look at this, can we divide this formula with any other number to get a simplest ratio? Yes, 2. Can we divide this? No, not. This is only the simplest ratio. 1 to 1, simplest ratio. This is not simplest ratio. See, for this formula we have two other ratios, right? This is one ratio. What is the ratio here? 2:4:2. 2 carbons, 4 hydrogens, 2 oxygens. 1:2:1. We have two ratios. Which is simplest ratio? Second one is the simplest ratio. So how to define empirical formula? The simplest ratio of all the atoms in a molecule is called as empirical formula. The simplest ratio of all the atoms. A simple definition. Simplest ratio of all the atoms. To write directly, CH2O. So for glucose, empirical formula is CH2O. Ethane. C2H6. CH3. Acetic acid. Can you tell me acetic acid empirical formula? Acetic acid, C2H4O2. You know name already, or read direct. CH2. Observe these two. Empirical formulas are same. So empirical formula may be same for two different compounds, but molecular formula is not same, always different. For two compounds, empirical formula may be same. You tell me atomic weight and equivalent weight, which will vary, which will constant? Atomic weight and equivalent weight, both will vary, or both are constant, or one is constant, one varies? Equivalent weight varies. Equivalent varies. Atomic weight is constant. Empirical formula is varies in the sense, sorry, same for two different compounds, but molecular formula is not same. Okay. Similarly for benzene, what is benzene? Benzene, online students. Benzene formula C6H6. Empirical formula CH. I'll ask you one question. Acetylene. What is acetylene formula, Gayatri? Formula. C2H2. Empirical formula. Huh? What C2H4? Acetylene. Ethylene is C2H4. Okay. Once look at this. CH to CH. Empirical formula is same. Procedure to find empirical formula. Note down one question. An organic compound contains 40 grams of A, within the bracket atomic weight is some 4 approximately. Okay, I'm giving random method, and 50 grams of B, within the bracket atomic weight is 5, and 10 grams of C, within the bracket atomic weight is equal to 5. Find empirical formula. Weights are given to you. Atomic weights also given to you. Okay. We have to find empirical formula. Generally, in the questions, in most of the questions, what they'll give weight percent. So 20% carbon means you have to take 20 grams.
A5, B5, C5.
See, instead of 40 grams, I can take 40%, because in the questions percentages only will come, but I took directly weights. What we have to do when we get the weight? Same procedure. If you get a percent, 40% or 40 grams, procedure is same, no change in the procedure. See how to do the question. Answer is A5, B5, C. Your answer? Correct only? A5, B5, C. Okay. Let us check. See the procedure. You will get mostly 3 elements. 2 elements or 3. Okay, maximum 3. In Roman number 1, you have to, means first column, not Roman number 1. First column, you have to write the element. In second column, weight. Third column, number of moles. Fourth one, simplest ratio of the moles. Simplest ratio. If you get percentage, then also same column. Column is weight only. Alright. How many elements are given? A, B, C. 3 elements are given to us. Weight of A, 40, 50, and this is 10. Okay. At number of moles, weight by atomic weight. Atomic weight is 4, 10. Here weight by 50 by atomic weight is 5. Here also 10. weight, 10 by atomic weight is 5, that is 2. After getting number of moles, simplest ratio, select the simplest value or small value among all the moles, which is smaller value 2. Divide remaining with the 2. 10 by 2, 10 by 2, 2 by 2, 2 by 2. 5, 5 and 1. So A5, B5, C. A5, B5, C. This is procedure. Remember the procedure, but data is a little bit tough. You will get like 23.7. Then what you have to take? 24. Relation between empirical formula and molecular formula. Molecular formula is equal to empirical formula taken N. What is N here? Molecular weight by empirical formula weight. Molecular weight by empirical formula weight. Let us do one question on this. If we know empirical formula, then we can find molecular formula. Sometimes after finding empirical formula, we have to find molecular formula, but sometimes they only will give empirical formula. We have to find molecular formula. See the question. An organic compound, empirical formula is CH2. Within the bracket, molecular weight is 180. Find molecular formula. An organic compound empirical formula is given. Organic compound molecular weight is given. We have to find molecular formula. Sometimes we have to find empirical formula. Okay, by using this procedure table before that I given. Okay. First of all, calculate empirical formula weight. EFW means empirical formula weight. What is empirical formula? First write empirical formula. Empirical formula is CH2O. Empirical formula weight. Add all these. 12 plus 2 plus 16. How much? 30. Empirical formula weight. Then N is equal to. What is molecular weight? 180 given in the question. 180 by 30. That is equal to 6. Now substitute in this. Molecular formula is equal to empirical formula. What is empirical formula? CH2O. CH2O N value 6. So C6 H12 O6. See, sometimes third element percentage will not be given to us. Then what we have to do? Subtract. Do this question. Okay, procedure is first column element is carbon, oxygen and hydrogen. Right, weight directly. 36% means 36 grams. 48% means 48. Remaining 36 plus 48. Add the 2. 8 plus 6, 14, 4, 84. 100 minus 84, 16. Number of moles. 36 by carbon weight 12, 48 by oxygen weight 16, and 16 by hydrogen weight 1. Hydrogen weight means don't take molecular weight. In empirical formula we take atomic weights only. Approximate value here, take approximation only. Approximately 12 into 3 direct 3 16, which is least value 3. Divide remaining with 3 by 3 and 3 by 16. Here we have to take approximation. Again we are getting fraction, but what we have to do I'll tell you. 1 this is 1 by 5.
So
16 by 3. Oh. Sorry, weight.
5.
Then formula CH5O. CH5O. Tell me. No. That only I am saying. If they give 36%, take weight. What is weight percent? Yesterday I explained, no? 36 grams of NaOHCO3 by weight means, what is the meaning for it? Madhiha, 36% NaOH by weight means, what is the meaning for it? 36 grams of NaOH present in 100 grams of the solution. In empirical formulas, they will mention percentages of the elements. Take them as weights directly. Okay, don't multiply. Don't do like this 36 by 100. 36% means 36 by 100 into 100. Don't do that type of calculations. Take as weights directly. Okay. Last topic. Oxidation states. Which type of questions we can expect based on the oxidation states? First, balancing of oxidation states, finding coefficients. Okay, and next question based on the types of reactions, redox reactions. What are the types of redox reactions? Combination redox reaction, decomposition redox reaction, disproportionation redox reaction. Which of the following is a disproportionation reaction? Which of the following is a comproportionation reaction? Something like that. And another model question is finding the coefficients. A very easy level questions are oxidation states. What is the oxidation state of chlorine in bleaching powder? +1, -1. +1 or -1? Both +1 and -1. Chlorine shows two types of oxidation states. That is simple question, but mainly coefficients finding in the redox reaction and types of redox reactions. Okay, let us start. Oxidation state. Basic definition of oxidation state is simple definition: charge over atom is called oxidation state. Oxygen -2, oxidation state is equal to -2. Magnesium +2, charge is +2, so oxidation state is +2. Aluminium, what is oxidation state? 0. Oxidation state may be negative, positive, 0 or fractional also. Oxidation state nothing but charge. Say first A group elements: hydrogen, lithium, sodium, potassium, rubidium, cesium. All these elements show +1 oxidation state. Second, beryllium, magnesium, calcium, strontium, barium, radium. +2. 6A group, mainly oxygen. Oxygen common oxidation state is -2. Halogens: chlorine, brominide, -1. See, if we know oxidation states of these elements, we can find oxidation state of any other element. Okay, so remember first is second is oxygen and halogens oxidation states. First we should know how to find oxidation state, and you already know, but I'll revise few important examples. You tell me in which oxidation state of the element is 0, in which type of compounds. Okay, in metals. Okay, if you take iron metal, the oxidation rate is 0. Next,
O2 H2. Gases.
gases type.
O2 H2.
Homoatomic molecules. Homoatomic molecules. Okay, did you finish? Now write some important points. Okay, some important theory points. In the following compounds, oxidation state of element is 0. What are that following compounds? In the following compounds, oxidation state is equal to 0. First, metal carbonyls. In complex compounds, we will get already over. Iron oxidation state is 0. Metal carbonyls. Nickel oxidation state is 0. Next, second one, amalgams. In amalgams, what is amalgam? Any metal in combination with mercury. Magnesium amalgam, sodium amalgam, zinc amalgam. In amalgams, oxidation state is 0. 0, 0, 0. And third, see the molecule in which same kind of atoms are present. Molecule in which same kind of atoms are present. O2, N2, Cl2. Here 0, 0, 0. Homoatomic molecules oxidation state is 0. In elements, for example, iron element, 0. Iron is in the free state. It is not in combination with any other element. Okay, iron metal, you took iron metal. When element is not in combination with any other element, then its oxidation state is 0. Single atom oxidation state is 0. The molecule in which same kind of atoms are present, O2, N2, P4, S8, S8. In this, all 8 are sulfur atoms only. Here also oxidation state is 0. Oxygen shows different oxidation states. Next, keep heading oxygen oxidation states. Oxygen oxidation states. In water, what is the oxidation state? What is oxygen common oxidation state? -2. In water, oxygen oxidation state is -2. In O2 molecule, 0. H2O2, Na2O2, BaO2, 3 important peroxides. In peroxides, oxygen oxidation state is -1. In peroxides, superoxides, potassium, rubidium and cesium. These 3 elements form superoxides. Superoxides formula KO2, RbO2, CSO2. Here oxygen oxidation state is -1/2. -1/2. In OF2, oxygen difluoride, O2F2, dioxygen difluoride. Here oxygen oxidation state is, fluorine is -1, right? 2 into -1, -2. Net should be 0. So what you have to take? +2. Oxygen is +2 here. Here -1. 2 into -1, -1. But net should be 0. +1. So oxygen generally shows negative oxidation states, but in which oxygen is showing positive oxidation states? in oxides or fluorides. What is the name for this compound commonly? You tell me, what is its name? Carbon dioxide. What is its name? Sulfur dioxide. What is its name? Generally, binary compound of oxygen is called oxide. Binary compound means made up of two elements. In that compulsory one should be oxygen, is called as oxide. Binary compound of oxygen is called oxide. Can we call this as oxide, Shweta? Oxide. Binary compound only, na? Made up of two elements, binary, and oxygen is there. So can we call it as oxide? Which of the following is not an oxide? OF2 is not oxide. Why? We cannot call this as oxide because when we call particular compound as oxide, in that oxide, oxygen should be more electronegative. Carbon and oxygen, which is more electronegative? Oxygen. Sulfur and oxygen, which is more electronegative? So we can call oxide. These two are oxides. But here, which is more electronegative? So don't call as oxide. Fluoride. Oxygen difluoride. Dioxygen difluoride. Which of the following is not an oxide? OF2 is not oxide. Fluoride. Dioxygen difluoride. So in these two, oxygen shows positive oxidation states. Negative, 0, negative, again positive. You tell me, in which of the following oxygen shows lowest oxidation state? See the board and tell me. In which of the following oxygen shows lowest oxidation state? What is lowest value? +1, +2. -1/2, 0, -1, -2. -2 is the least value. So in water, oxygen shows least oxidation state, lowest value. Highest oxidation state of oxygen is present or is observed in fluorides. Oxygen difluoride and dioxygen difluoride. Some important oxidation states of oxygen. And zero oxidation states also explained. Carbonyl compounds, metal amalgams, and molecules in which same kind of atoms are present. Oxidation state do not exceeds group number. Correct or wrong statement? 4th A group elements maximum oxidation state is +4 only. 6th A group elements maximum oxidation state is +6 only. Oxidation state do not exceeds group number. 7th A group elements maximum oxidation state is +7 only. Chlorine +7. Right. Finding oxidation states. Finding oxidation states. In one, sulfur. In second one, find nitrogen. In third one, for iodine. Fourth one, some Cl2. In first one, sulfur oxidation state is +6. See the procedure. What is the procedure? First, write the known elements oxidation states. Hydrogen is +1. Oxygen is -2. Yes, answer 6. Consider unknown element oxidation state as X. 2 + X, 4 into -2, -8. Equate the sum to 0. So X is equal to +6. In NO3 minus, nitrogen is +5. Okay. I'm writing directly +5. You know, for negative, any doubt? NO3 minus. How to find oxidation state for ions? Kirti, it telsa chappala. Audio. I minus -1 already given directly, -1. And Cl2 home atomic molecule. Here it is 0. Gayatri, idana doubt unda? Vasavi. Then do this. Gayatri and Madiha. క్రోమియం కార్బన్ మ్యాంగనీస్. శ్వేతం వచ్చా నీకు? ఇది ఐడియా ఉంది కదా? ఒక్కసారి నా కన్ఫర్మేషన్ కోసం చెక్ చేస్తాను. సి దిస్ ఈజ్ అయాన్ నాట్ న్యూట్రల్, సో వీ షుడ్ ఈక్వేట్ టు చార్జ్ x, 2 into x, 2x, 7. Oxygen is -2 and again -2 is there. So after simplification what we will get? +6. Here 2x minus 2 into 4 is equal to -2 or 4 into 2. 2 into 4 or 4 into 2. 4 into -2. X is equal to +3. In MnO4 minus +7. Right. Next one important question, number of electrons involved. So we are going from the basics to model questions, right? Number of electrons involved in the following reaction. Next question. Number of electrons involved in following. How many electrons are involved in this? Two,
6.
in this one electron is involved. Gayatri? Okay, let us do one thing. Let us do simple question. First of all, you tell me MnO4 minus gives rise to Mn plus 2. Let us do this. Okay, later come to that. What is the oxidation state? +7. +7 to +2. 2 is given already. What is the change in the oxidation state? 5. So 5 electrons are involved. Once observe, is there any subscript? How many manganese atoms are there? 1 manganese. So if one atom is present, you take change directly, no need to multiply with any number. Take change directly, higher minus lower. 1 Mn is present. Normal difference is nothing but change in the oxidation state, nothing but change in the electrons, number of electrons required. Here chromium is +6. After calculating we will get a +6. +6 to 3. Change is 6 to 3. What is the change? 3. But subscript is 2. Multiply with 2. So 6. So 6 electrons are involved in this. 6 electrons. Here also same. Oxidation state is +3. Here +4. Higher minus lower. 3. 4 minus 3, 1. But subscript is 2. So change in the oxidation state is 2. Change is equal to 2. Here change is equal to 6. Here iodine. Iodine oxidation state 0. 0 here -1. You tell me 0 to -1 means how much change? Do like this, -1, -2, 1, 2. When you get negative values, this is best technique. -1 to 0, how many units you are changing? 1. So 1, but subscript is 2. 1 into 2. Okay. 0 to -1, what is the change? Write like this, -1 to 0. 1, this is 1 unit only, but subscript is 2. Right, next. Next heading, oxidation reactions. Reduction reaction. The reaction in which oxidation state of the element increases is called as oxidation. +3, this is +4. Reduction reaction, the reaction in which oxidation state of the element decreases is called as reduction reaction. This is +6, that is +3. Okay. Can I consider this as oxidation reaction? Can I consider this as oxidation reaction? Oxidation means increase in the oxidation state. Increase in oxidation state. Decrease in oxidation state. O state, oxidation state. Is this oxidation?
Yes.
0 to -1. Decrease. Reduction, this is reduction. Okay. What about this? You tell me. I/3 - 2 gives rise to I2.
Oxidation.
Reduction or oxidation? What is iodine oxidation state on the left hand side? +5 to 0. Decrease. Reduction. Okay. Oxidation reaction, reduction. Juhi, can you write the test instead?
No.
Sit outside and write, okay? Because you know, if you remind me, then I'll give before that.
I was reading it.
Okay, go and write, no problem. Gayatri, రాస్తావా టెస్ట్ వింటావా బేసిక్స్ బ్యాలెన్సింగ్ వాసవి కొంచెం ఏమన్నా డౌట్ ఉందా కీర్తి నీకు Redox reaction. See, zinc is 0. Sorry. Zinc is 0. 0 to +2. Increase or decrease? Increase. +2 to 0. Decrease. This is oxidation or reduction? This is oxidation. And this is reduction. The reaction in which both oxidation and reduction takes place is called as redox reaction. Both oxidation and reduction. Redox reaction, very important question is balancing the redox reaction. Next, types of redox reactions. Okay, let us do balancing of redox reaction in shortcut method. Balancing of redox reaction. Later we will go with the classification of redox reactions. First, let us cover important question. Balancing of redox reaction. You also give the space like this. MnO4 minus, give some space to write the numbers. Fe+2 and again space here. Some space. What we will get? See, in the question we will get A here, B, C, D. Find out A, B, C, D. In the question we will get A, for example like this, A, B, sometimes hydrogen also, C, D. What are A, B, C, D? That is the question. Okay, if we balance then we can find A, B, C, D. While doing the question, you have to take skeletal equation. They will give A, B, C, D in the question, in the reaction. Ignore them and take simple plain equation. And don't take H plus water molecules. If they mention H plus, then don't take. If they mention H2O, then also don't take. Just to take plain equation. Take plain equation, simple equation. See the procedure. First step is find the oxidation state of unknown elements. What is manganese oxidation state here? +7. Here +2, +2. Find the change. What is the change? 7 minus 2, higher minus lower. Change is 5, higher minus lower. Here iron +2 directly given, here +3 directly given. What is the change? 3 minus 2, that is equal to 1. Do cross multiplication with the changes. 5 is the change in the oxidation state of manganese. So take this and multiply with iron. 1 is the change in the oxidation state of iron. Multiply with the manganese. Cross multiplication. Take manganese change, multiply with iron. Take iron change and multiply with the manganese. Okay, and don't multiply products side. Multiply on the left hand side, reactants side only. Manganese, this should be multiplied by 1. So 1 MnO4 minus 5 Fe plus 2 gives rise to, right here as it is, Mn plus 2, give some space, Fe plus 3. This is step 1. Next, balance the atoms other than oxygen and hydrogen. Other than oxygen and hydrogen. Here how many manganese atoms are there? 1. Here 1, already balanced. Here how many irons are there? 5. Keep 5 here. Next, balancing of oxygens. Left hand side, how many oxygen atoms are there? Left hand side, how many oxygens are there? 4. What we have to do to balance number of oxygens? We have to add water molecules. How many water molecules we have to add?
4.
We need 4 oxygens. So write 4 water molecules on the right side. 4H2O. 4H2O. When we add water molecules, new atoms are entered. What are the new? Hydrogens. How many hydrogens entered? 8. So to balance hydrogens, we have to write H plus. How many? 8. 8 H plus ions. Over. So A is equal to 1, B is 5, C is 8, D is again 1. First, we have to find the unknown elements oxidation state. Then do cross multiplication with that changes. Balance the atoms other than oxygen and hydrogen. Next, balance oxygens. To balance oxygens, we add water molecules. Next, balance hydrogens. If any subscript is present, you know what we have to do. Do this question. Online students, did you get this? Do this. Alphabets A, B, C, and without considering H plus water. Take skeletal equation. Cr2O7 minus 2, C2O4 minus 2, Cr plus 3. Let us see whose answer will be correct. Chromium oxidation state is +6. +6 to 3. Change is 3. Subscript is 2. 2 into 3, 6. Here +3 +4. Change is 1. But subscript is 2. So 2. See, when we get, once look at this. 2 changes, the two changes can be divided by any number, then you can divide. Can we divide these 2 numbers with any other number? Hey, say that number. So can we take 3? 1. 6 into both are divided by 2. So 3, 1. You can keep like that also, but finally you have to divide. After final balancing, if all the coefficients are divided by any other number, then we have to divide. Okay, do cross multiplication. Carbon change is 1, so 1 Cr2O7 minus 2 plus chromium change is 3, so 3 C2O4 minus 2, Cr plus 3 and CO2. Next, balance the atoms other than oxygen and hydrogen. This side, how many chromium atoms are there? 2. So write 2 here. 2. Here, how many carbons are there?
6.
3 into 2, 6. 6 CO2. 6 CO2. Left side, how many oxygens are present? How many, Madhika? 7 here. 3 into 4, 12. 19 oxygens are there. 3 into 4, 12. 7. Right side, 6 into 2, 12 oxygens. More, how many oxygens we need on the right side?
7.
19, this is 12, 17. 7, sorry. 7. So how many water molecules we have to add? 7. So this side 7 H2O, 7 H2O. When we add water molecules, new atoms are entered, hydrogens. How many entered? 14. 7 into 2, 14. So this side plus 14 H plus. Who got the value? A is equal to 1, B is equal to 3, C is equal to 14, T is equal to 2. Pragnikas. Answer is correct. Kirti, idna was second time. See, let us do one more question, important question, but not balancing, different model. Balancing is over. Next question. The moles of MnO4 minus is required to oxidize 1 mole of C2O4 minus 2. 1 mole of C2O4 minus 2 in the following equation or in acidic medium. MnO4 minus plus C2O4 minus 2 gives rise to Mn plus 2 plus CO2. Equation will be given to you, no problem. Okay, right, important question, student. What is the change in the oxidation state? Plus 7 to plus 2 change is 5. Okay. Here change is plus 3 to plus 4 change is 1, but subscript is there, so 2. What we have to do, tell me? We have to do cross multiplication. Kirti Jude. What is the change in the carbon? 2. Multiply with this 2 MnO4 minus. What is the change in the manganese? 5. So 5 C2O4 minus 2. You can ignore right hand side. Actually, this is different question, not related to balancing. No, we need these two only. You tell me mole relation. To oxidize 5 moles of C2O4 minus 2, how many moles are required? 2. Then to oxidize 1 mole, how many? That is the question. To oxidize 0. To oxidize 5 moles, how many moles of MnO4 are required? 2 MnO4 moles, 2 moles. But in the question, to oxidize how many moles? 1 mole only. For 1 mole, question mark. X is equal to 2 by 5. Correct only, no? 5x is equal to 2. X is equal to 2 by 5. 2 by 5 means 0.4 moles. This is another model question. Okay, but related to balancing concept only. And you know what are the equivalent weights of oxidizing agent and reducing agent? We know equivalent weight of acid. How to find equivalent weight of acid? Molecular weight by basicity. Equivalent weight of base, molecular weight by acidity. Equivalent weight of salt, molecular weight by charge over cation or anion. Similarly, equivalent weight of oxidizing agent and reducing agent. Keep it. Equivalent weight of oxidizing agent or reducing agent. Equivalent weight of OA or RA, oxidizing agent or reducing agent. First of all, tell me what is oxidizing agent, what is reducing agent. Look at this. 0 to +2. Increase or decrease? Increase. This process is called oxidation. +2 to 0. This process is called as reduction. Okay. The one which is undergoing oxidation is called as reducing agent. Reducing agent. Which is undergoing oxidation? Zinc. Zinc oxidation state is increasing or not? So zinc is undergoing oxidation or not? So that is a reducing agent. Reverse. The one which undergoes oxidation is called as reducing agent. Zinc is reducing agent. Reducing agent. Copper +2 is undergoing 2 to 0 increase oxidation. The one which undergoes oxidation is called as reducing agent. Cu+2 is the reducing agent. Oh, sorry, Abbu. Very good, very good. Baga conscious ka. Absent law. Oxidizing agent. What is the equivalent weight of oxidizing agent in the following reaction? So first we should find which is oxidizing agent, which is reducing agent. Clear? That's why I give an introduction about oxidizing agent or reducing agent. Reducing agent or reductant, another name. Oxidizing agent or oxidant. Oxidant, reductant. Formula of equivalent weight of oxidizing agent or reducing agent. Equivalent weight of OA, oxidizing agent or reducing agent, is equal to molecular weight of oxidizing agent OA or RA, reducing agent, divided by change in the oxidation state or N factor, change in oxidation state. For oxidizing agent or reducing agent, equivalent weight is equal to molecular weight of oxidizing agent or reducing agent divided by change in the oxidation state. C1 model question. Find equivalent weight of KMnO4. Within the bracket, consider molecular weight as capital X. Molecular weight as capital X. Value is 158 actually, but they will give the data. They considered a molecular weight as X in following reaction. KMnO4 plus Fe plus 2 gives rise to Mn plus 2 and Fe plus 3. Molecular weight is given to you already, X, capital X. Find change in the oxidation state. What is the manganese oxidation state on the left hand side? Potassium is +1. Potassium belongs to first A group, +1. Manganese is X, oxygen is -2. Okay. 1 plus X, 4 into -2, -8 is equal to 0. X is equal to +7. +7 here, +7 to 2. What is the change? 5. So equivalent weight of X by 5. You tell me, in this reaction what is oxidizing agent? In this reaction what is oxidizing agent? KMnO4. Why? Because it is undergoing reduction. KMnO4 +7 to +2 undergoing reduction, so it is oxidizing agent. Which is reducing agent? Fe plus 2. Fe plus 2 is undergoing oxidation. Plus 2 to 3, iron is undergoing oxidation. So it is a reducing agent, reverse. The one which undergoes oxidation, so this is reduction, oxidizing agent. Oxidation, reducing agent. In this reaction, Fe plus 3 is reducing agent. Okay, reducing agent or oxidizing agent. మీరు అట్లా కన్ఫ్యూజన్గా చూసి నన్ను కన్ఫ్యూజ్ చేయకండి. Fe plus 2 is undergoing what?
Oxidation.
So that is reducing agent. Manganese undergoing what? So that is oxidizing agent. Okay. One question for you. Okay. Change in manganese oxidation state in different mediums. In different mediums. Acidic medium, neutral are also called as weakly basic medium or alkaline medium, and strongly basic medium or alkaline medium. Strongly basic, weakly basic, strongly basic. Neutral or weakly basic, both are same. MnO4 minus gives rise to Mn plus 2. MnO4 minus gives rise to MnO2. You only tell me. MnO4 minus gives rise to MnO4 minus 2. Consider molecular weight of KMnO4 or MnO4 minus as X. Give the answer. In acidic medium, what is the equivalent weight? Find changes in the oxidation state. X by dash. Here X by dash. Here X by dash. And first one is X by
5.
X by 5. So in acidic medium, equivalent weight of potassium permanganate is molecular weight by 5. In acidic medium, you have to by heart these reactions. You have to by heart this. In neutral medium or weakly basic. Here
X by 3.
plus 7. In MnO2, plus 4. X by 3. In strongly basic medium or alkaline medium, X by 9. X by 9. 9. NINE 9.
X by
Or ONE 1.
X by 1.
X by ONE 1 or NINE 9. X by TW2.
X by 1.
1. This side plus 7 and this side you will get a plus 6. So equivalent weight is equal to molecular weight by 1. Okay.